Hello, Matthews Gatos here. In this video, I'm just going to review section 5.2 with a monomial and a binomial denominator. So let's start with the monomial. The expression 20 root 5 over root 10 minus 16 root 8 can be expressed in the form k root 2, where k is a whole number. We want to find the value of k. So let's try simplifying. First thing that I notice here with my roots is that 5 and 10 have a common factor. So to make my life a little bit easier, I'm going to write the whole root together like that and then simplify. I also notice that root 8 can be broken down into its perfect factors, root 4, root 2. So over here I have 20, the root of 1/2, 5 over 10 in lowest terms is a half, minus 16 over square root of 4 is 2 root 2. Now let's simplify this by separating them into two different radicals again, as they started, minus, here 16 divided by 2 is 8 root 2. Now I can see that I have a common denominator of root 2. So 20 times root 1 is just 20, so I don't really need the root there. So now all I have to do is subtract. 20 take away 8 is 12. So I have 12 over root 2, but you can see in my expression there, I don't have a fraction. That's because we rationalized the denominator. So in my next step, I'm going to rationalize the denominator by multiplying top and bottom by root 2. So root 2 divided by root 2 is 1, and I can multiply any expression by 1. So I'm going to end up having 12 root 2 over root of the same thing times root of the same thing is the same thing without the root. And then all I have to do is 12 divided by 2 is 6. So my answer is going to be 6 root 2. And I can see that fits in with my template. I always like to write it right underneath to make absolute sure. And I can see now that k is equal to 6. So let's check this to see if we did it correctly. So there's my original, and I found the numeric value because there's no variables. And there's my answer, 6 root 2. They have the same value, so I know I did it correctly. Okay, let's look at when I have a binomial denominator. So before I start simplifying, I want to talk about the restrictions. So I have double trouble, and anytime I have a variable in the denominator, I have double trouble. So what I mean by that is I can't square root a negative, so 3x has to be greater than 0, and I also can't divide by 0. So negative 5 root 3x plus 1 can't equal 0. So I have two restrictions I have to look at. So let's look at this first one. I'll divide both sides by 3, and I get x greater than or equal to 0. Well, that was easy. The other one, a little bit more complicated. So I have negative 5 root 3x plus 1 can't equal 0. So I am going to add 5 root 3x to both sides. I always like the term with my variable to be positive. So that's gone. So I have 1 can't equal 5 root 3x. So to get the x by itself, I will divide both sides by 5. So I get 1/5 can't equal root 3x. To get the root gone, I will square both sides. I get 1 over 25 can't equal 3x. And then I just have to divide both sides by 3. So x cannot equal to 1 over 25 divided by 3 is 1 over 75. So my restrictions are that x has to be greater than 0, but can't equal 1 over 75. And you have to do that anytime there's a variable in the denominator. So now that we know the restrictions, let's simplify the expression. So in the denominator, I have a binomial, and I'm just going to write it a little bit differently than it's written there. Instead of starting with the negative, adding a positive, I'm going to flip it around and start with the positive and subtract the negative. I'm doing this because to me, the conjugate will be simpler and with less negatives. If I have less negatives, there's less chance I can make a mistake. So now that I've done that, I'm going to multiply the top and the bottom by the conjugate. So the conjugate is same terms, opposite sign. And I'm doing this to create a difference of squares. That's really the only way I can square both terms of the denominator. So I'm doing this for the benefit of the denominator. I'm going to leave my numerator factored. There's no value to distributing 6 in, and in fact, factored form is simplest form, so I'm just going to leave it like that. In the denominator, I have 1 times 1, 1 times 5 root 3x, negative 5 root 3x times 1. There you can see my middle term is gone. And then negative 5 root 3x times 5 root 3x is negative 25. Root 3x times root 3x just becomes 3x. So keeping my numerator factored, it becomes 1 minus 25 times 3, 75x. Okay, so now that I've done that, I'm going to do my check, but because there's a variable, my check always happens in the table. So in y1, I put my original. In y2, I put my answer. You can see y1 equals y2, so I know I did that correctly. So I hope this little review of 5.2 helped, and I'll see you for the next one.